Hello friends, welcome to our YouTube learning channel Accurate ASME ISO. This video is going to be a very special video for everyone who are using 3-coordinate measuring machine or doing the programming. It will explain about a CMM programming language DMIS standard. DMIS stands for Dimensional Measuring Interface Standard. Many of us not have much clarity about this standard, but it will certainly help many CM programmers once the benefit of the same are understood. So let us begin with. Also, please do not forget to subscribe this channel and forward to your friends. Now, the DMI standard became an international standard. ISO released it with ISO 22093 and also it approved by ANSI, American National Standard. This international standard used for programming coordinate measuring machines. It defines a language and protocol for the measurement and reporting of dimensional data. DMIS allows users to create measurement programs that can be used by various CMMs, regardless of make and brand. Making more simple, we can say that users do not require to learn different softwares of different make machine, but learning one single programming language useful for all with little efforts of learning of the operations of CMM software. What made to develop a DMIS standard? Let us discuss few practical challenges user and organizations facing before. Traditionally, each CMM manufacturer created its own programming language for their measuring software. Even many offered multiple software packages, each with a different programming language. This means that most installed CMMs, even from the same suppliers, could not run each other's inspection program. It consumed a lot of time making the program for the same component on every CMM and separately. The user trained on one CMM software could not do program on another. Many technical challenges like special commands and features not available in all the softwares. Therefore, finding the results with same method became sometimes very cumbersome. The output report and its format varies software to software, and it challenged to read by production, design, or other than CMM users. In short, uniformity maintenance was the biggest challenge. One of the key benefits of DMIS is its ability to facilitate interoperability between different CMM and measurement software. Here, interoperability refers to the ability of different systems, applications to work together and exchange information efficiently. This can be achieved through standardized protocols. Same way, by using DMIS, a measurement program created for one machine can often be used on another machine that supports the standard. Let us demonstrate with graphics as follows. There are two different CMMs shown here. Those may be of different make, brand, or different softwares installed. It is a CMM of Make, suppose A, having the application software A, and part program created, suppose called A. Now, suppose there is another CMM. The CMM is maybe of Make B, having the application software B. Now, can we load the program created at CMM A with software A into the CMM B on its software B? So, once we can say that if program is compatible to DMIS language, that means program created in DMIS and the feasibility is supported at CMM A and CMM B, then we can say that the program created at CMM A is easily loaded in the CMM B and it would run as it is. So this is the advantage of the interoperability of the DMIS standard language. This DMIS language specifies how to describe measurement tasks such as probing points, lines and surfaces, and how to control CMM during the measurement. It means the movement of the probe on the various features available on the part. There are various other advantages of using DMIS program. Part program transferring. DMIS being a standard language, that part program created in one machine, irrespective of the brand and software, can be used on another machine. It doesn't make any difference if you have a local good brand CMM purchased for local advantages, because you can use directly your client's part program created at any location of the world. Even same program is used at different plants on different Make CMMs once created at one place. Flexibility of buying CMM as a choice. There is no need to buy the CMM of exactly the same brand or software, but buyer has a choice for many consideration in futuristic and commercial needs. Also, no organization can force any supplier to purchase identical CMM and software, as no necessity remains in case of DMIS language programming. Absence of threat of brand or software. There is no fear that if any of the CMM supplied company is closed out or the company has obsolete the old software and no support extended. CMM user availability. Because of the standard programming language, many engineers can learn the language and available as good workforce for the industries. Indirectly throughout, and productivity increases multifold of the industries. DMIS support many sensors. DMIS based software has no restrictions to any of the probing systems like touch trigger, scanning, optical, etc. Also, any of the applications like prismatic, freeform, sheet metal and etc. Dimensional measuring equipment, generally known as DME, a class of equipment used to inspect parts and evaluate dimensions and tolerances. DMEs include but are not limited to coordinate measuring machines, video inspection equipment, optical comparator, robotic measuring devices, theodolites, photogrammetry and laser-based measuring devices. Let us understand about the DMIS committee, who has developed this language. The DMIS language was developed by DMIS Steering Committee, which is a part of the coordinate measuring community also. The development and maintenance of the DMIS standard involve collaboration among various stakeholders, including manufacturers of CMMs, software developers, and industry experts. The DMIS Forum's official website is www.dmisforum.org. The site provides access to the DMI standard documents, updates, and information about the committee's activities. It is a valuable resource for anyone involved in the field of dimensional measurement and the CMM programming. To understand better way the DMIS programming language, its commands and definition statements, for examples. The various statements described, consider the following list of valid DMIS statements. The first line is a command directs the fine positioning feature of the DME to be enabled. The second line prescribes the size, location and orientation of a feature that is a circle and assigns to it the name circle_1. With the line continuation character $, this statement is continued on the third line. The fourth line is a command statement directs the DME to measure a circle. The next line is a command statement that directs the DME to move the given position. The next three lines are command statements that direct the DME to take point measures at the given locations. The last line is a command statement indicates that the measurement sequence is complete. Many of the users may think that how I can write the program which is in a very typical kind of a text to be written as shown in the program. But user need not to worry about typing of the text or coding of the DMIS language. The text commands are automatically written. I repeat it because it is very important. The text commands are automatically written when we click on the icons shown on the software GUI, graphic user interface. So when we open the software and find the icons, and when we click it, automatically what we click on, the beneath of that icon, what statement is written, it get added on the program window. You can see again in the video of the programming shown in the last slides. One of a very important advantages of the DMIS language programming is that we can write a macro programming. Macro programming is a short program which can be taken as a subroutine program in the main program, and that the macro program is readily available. For example, a repetitive requirement of the measurement. What we show in this drawing is the whole pattern to be inspected with a macro routine. Here we see that it is a whole pattern of 4 holes. Suppose every time in the new component we got a different kind of the whole pattern, but we can easily call out the subroutine for the measurement of that macro, and the parametric changes can be done according to the center distances as well as the diameters. So it saves a lot of time of the programming, or some of the critical the pattern measurements is made by some of the experts, so that anyone the follower of the programming is just make it insert in the required main program. We have discussed a lot many advantages, benefits of a DMIS programming language. On the same time, we cannot ignore that there are certain challenges also with DMIS programming. Since it is a standard, and the standard also has got certain the versions releases, so some of the times you have to really think of the which software content of which commands of which versions. So that information is available in characterization file, a file created by a vendor that lists DMIS statement and function it supports. So anyone can see the characterization file and he can find out whether the statement is something missing or the required statements are all available. The characterization files that describe the extent of DMIS support. The file is an ASCII file specifying which statement in the DMIS vocabulary are supported, partially supported, or not supported. This file will contain the description of statements for input and output formats of all DMIS statements, as well as other information concerning the system's capability or limitations. The other challenge could be the user knowledge. A high level of expertise certainly required while using high-level language commands and statements like parametric programming, looping statement, if-else conditions, macro programming, etc. So rather than understanding only normal DMIS, when you want to understand the fullest benefit, making very good the language usage, then a certain knowledge essential to make the program. Editing of the DMIS programming is not easy in case if support commands and statements are limitations, while transfer of the program from one DME to another. When we transfer the program, it could be possible that the another DME, means the machine, has got different probing system, different alignment requirement. So some of the times the same command may not be available. So that time the editing becomes a little challenging for the user. But a good trained user, knowledgeable user overcome all these obstacles and he can make the program through.
Hope that you like this video. Please do not forget to subscribe the channel and share it to others. For training inquiry, please find the contact details on the slide. Thank you friends. Take care. Bye for this time. See you soon for the next video. Thank you once again.
Hello everyone, my name is Aniruddha Doshi and I am the manager at Majorville Technovision Private Limited. So I opt for this Occam course through Accurate under the guidance of Momin sir. So this course was about 5 days and there it was the basic understanding of metrology and then to the advanced level. So the course was very organized and the teachings were very simple and we can get the idea of that complex metrology systems very easily. So Accurate and Momin sir, they are very much we are thankful to them that they are doing this contribution to this metrology field and work. So thank you so much.